This will be a series of videos on how to repair the regulators used in Hammerli air pistols that work with the AP40 style cylinders. There's the AP40 pistols, but once they had designed the regulator system for the AP40 cylinders, Hammerli also came out with a conversion system to convert older Hammerli 480K air pistols to use the AP40 cylinders. And the design is a little bit unique because the regulator, in most other air pistols, the regulator system consists of a piston with some sort of spring that opens and closes a valve, and the valve is part of the regulator hardware in the pistol. In the AP40 design, the regulator is kind of split into two pieces. There's the piston and spring system, which lives in the pistol, and the valve that is used to control the pressure is actually the valve in the cylinder. So that simplifies the design of the regulator quite a bit, but it does add additional constraints on the manufacturing of the cylinders because that valve now has to open at a consistent setting with the operation of the piston and the regulator. The AP40 regulator is housed in a small steel cylinder, and all that's inside that is a piston and a spring goes over the back of the piston, and then there's a small adjustment bushing that has two pinholes in it for use with a small spanner. And the conversion for the Hammerli 480K uses all the same internal hardware, but there's an aluminum adapter that replaces the entire regulator assembly of the 480K with a threaded front section that the AP40 cylinder screws into, and then it contains the regulator components. Before we can get into actually working on the pistol, you're going to need a certain amount of tools and materials to go through the process. And in terms of materials, I like to have a bunch of small pieces of paper towel to help clean things and get grease and oil off my fingers. You're going to need toothpicks, just regular stored toothpicks. For cleaning and spreading grease around inside the pistol components, I like to use small foam swabs. The advantage of these is that they don't leave lint behind the way cotton swabs can, because even a single thread of a cotton swab can interfere with proper sealing of O-rings and the like. And there's going to be a list with sources and materials in the notes with the video that has places where you can purchase these things. In addition, to lubricate particularly the seal, this is a super lube synthetic grease. It's O-ring compatible, and I use that for all of my air gun repairs. The super lube also makes a synthetic oil, which is good for sort of general lubrication of the moving parts. The thing that tends to die in these is a small rubber seal. It's not actually a true O-ring. It's what they call an X-ring or a quad ring. And if you look at the cross section, rather than being round like a regular O-ring, it's sort of in an X shape, and it actually has the arms of the X form four sealing surfaces, and that basically produces a lower friction seal. And these are a standard US size ring. The ones that I found are a hardness or durometer of 70, and these are what's called the Buna-N or nitrile material. These work very nicely. I think going to a harder X ring with a durometer of 90 might hold up a bit better, but I haven't been able to locate those, and I'm still working on that. But you're going to need the seal, and again, sources for that are in the notes. Just to sort of help clean things a lot, I use can duster. They sell these in electronics and computer stores, just to blow out debris and dry things off. I also, in terms of a cleaning solvent, I like this CRC QD cleaner. It's low residue, it's plastic safe, and the QD stands for quick drying. It evaporates very, very quickly. Another thing that can be useful is a small quantity of acetone in a little jar, because depending upon how gunked up the internal parts are, a bit of a soak can be useful. It's helpful to have an ultra fine tip marker to sort of mark where various things are before you take things apart so that you can put it back together. And it's also helpful to have a notepad and a pencil or pen to make a few notes, once again, to help ease reassembly. In terms of tools, you'll need a 2.5 millimeter hex key to take the grip off. You'll need a small flat-bladed screwdriver to remove the trigger. The key thing that's a little hard to come by is a special regulator tool. If you look at this carefully, it has two short pins, and those engage the hole in the holes in the adjustment bushing in the regulator, and you use this to take it apart, put it back together again, and if need be, to adjust the velocity once the regulator is reassembled. And this is 3D printed with the pins, sort of a U-shape system. I've printed up a whole raft of these, and you can contact me if you need one. In an emergency, another option is to cut down a large paper clip and then use a pair of pliers to work with the bushing. The bushing does not require a ton of force to screw and unscrew, which is a big help. I also have a pair of flush cutters, and that's basically to shorten the length of the cotton or the foam swabs that I use for cleaning. You have to do everything from the back, sort of working inside the trigger area, and this allows you to cut the handles down on the swab so that you can get in there a little bit better. Tweezers are helpful if you have to fish things out of the acetone. A small flashlight is also helpful to see down inside the back of the regulator housing in the pistol. And Once you get everything back together, it's helpful to have a chronograph. It's not essential. If you take careful notes of where things were set, when you take it apart and you put it back together again, you'll have an operational air pistol. It may not be firing at exactly the recommended velocity, which is 475 feet per second, but it should shoot just fine, and you may require a sight adjustment, but it's not going to be anything major. So that covers the tools and materials, and next we'll get on to disassembly.